In this video, I'm going to teach you what are Kubernetes probes, when to use, which one and why they are very important whenever you are deploying any application. So we have three types of probes which you must use whenever you deploy an application. One is the startup probe, second readiness probe, and third is liveness probe. So first we will talk about the startup probe. As the name says, startup probe, this probe is run only once during the time when the container is starting, or the pod. I will be using the word container because the application will actually run inside the container, right? So this startup probe is kind of a at job. We all are coming from a Linux background and we know what is at, right? So at does a one-time execution. So when the container is starting, I might have to check some file or some port whether it is working properly or not. Let me give you one simple example. If suppose I am running a web server in my container. So if I am running a web server in my container, a very easy check can be, if I am running Apache, right? A very common check can be if, say, port number 80, right? Port 80 is working or not, right? Is it listening the request or not? Or I can simply check a file, say var www.html, right? Index.html, that is the first file normally which the application accesses. I'm just giving a very simple example. So if this port is working properly, or if the the Kubernetes is able to access this file, that means the container has started up successfully. Startup probe, right? Startup, whether the container has started or not. Only when the startup probe is successful, right, the Kubernetes will start sending the traffic to this pod. It's a one-time execution, guys. One-time execution. You need to remember this. And something like this. It is used as a signal whether the application is successful or not, right? So sometimes it might take some time for the container to start. So we should give him a time before we should start sending the actual traffic to the container, right? One-time job. It's a one-time. So in this example, let's suppose I'm trying to cat this file, cat etc hostname, right? So in this case, if you see here, I'm putting this, that check this file etc hostname, right? And period second means once the container has started, give him a 10-second delay. And after 10 seconds, check this file etc hostname. And if the file is found, wonderful. If the file is not found, then I had explicitly mentioned here the failure threshold as 5. Fine. If the file is not available once, not a problem. So for 10 seconds it will come. If the file is available, perfect. The container is ready, right? The request will be coming onto it. If in case the file is not found, failure threshold is 5, means 5 times the Kubernetes will try to find this file. That means total is 10 into 5, 50 seconds, right? So even after 50 seconds, if I'm not able to access this file, that means the container is not ready and will be restarted. So let's check it out, the startup probe first. So this, the first thing that we are going to do is check the startup probe. So I had done some homework before this video. I've created some files. So first I'm going to check a deployment which is going to use the startup probe, right? So let's open this dep startup.yaml. This is a deployment. Name is startup. Label, ignore this. I'm going to create 3 pods. Every pod will have a label of app readiness. You know all this stuff. The important part is this. The important part is this. This is my startup probe. Check it out, right? This is my startup probe. So what I'm going to do in the startup probe, that the moment the container start, right? The moment the container start, the Kubernetes will make sure that he will be able to access this file, var www.html index.html, right? For 10 seconds, means once the container is started, after 10 seconds, it is going to ask for the file, hey, can I access index.html? If the index.html is available, wonderful, means the container is started and the request will be coming onto the container, right? But if there is a failure of one time, so I will not consider the container down for the first, right, at the first time. It will check 3 times. Failure threshold is 3. That means for 30 seconds, if the Kubernetes is still not able to access this file, the container will be restarted because the application didn't started successfully. So there is no use of sending the traffic then. So what I do here for you, I will intentionally make it wrong, right? To show you that it will not work. And remember, it's a one-time job. So suppose I had done a typo, I had intentionally done an index 2x. Then obviously we don't have this file, index.index with 2x. .html. I run this, I do a kubectl create -f dep startup. Check it out, guys. So it is running, but if I do a get deployments, I can see the deployment here. I can see a replica set, but if I do a pods, it is running. Let me check first one, right? I describe it, kubectl describe pod and the name of this pod. If I check it out, it says startup pro failed, right? But the container is still not restarted because it will take 30 seconds, right? First time it has failed. None of the application, none of the container is started. Now, if I again do a describe of this pod, see the container nginx failed the startup probe and will be restarted. And if I do a get pods, you can see all the pods have restarted automatically. Now think of it. If you don't have a startup probe configured and something happened, whether the service is not available, the developer has created the file with a wrong name, any typo could have happened, then the traffic, the Kubernetes has no way to find out whether the container is running or not, right? It will start sending the traffic, which will be a nonsense happening in my cluster. I'm going to stop it. So that is, but the way it works, I'm going to delete it. Kubectl delete -f dep startup.yaml. It has been deleted. Now what I do, I will intentionally change it, right? Now I make it right. Now this one is good, right? Index.html, which exists. Now I save and come out. Let me run this again. So if I do a create, it is very cold here today in Delhi, but fine. The work will go on. So startup.yaml, perfect. Now if I check it, kubectl get deployment startup, or just press enter here, running up, right? Kubectl get replica set and kubectl get pods. Everything is working properly. Wow, that is cool. But the point is how I am going to access this application. So 3 pods are running successfully. The startup probe has been successful. Let me show you in describing this. So if I give a kubectl describe pod, you need to be patient and see it carefully. It is started successfully, right? And I can see their startup probe is success. Perfect, right? And my timers and all these things are coming up here. So, but how I am going to, or how my customers are going to hit it? Am I supposed to give them the pod IPs? No. What I'm going to do, I'm going to create a service, right? So these are the 3 pods which are running here, pod 1, pod 2, pod 3. I'm going to create a service, right? This service will be connecting to the pods, right? And service will have a fixed IP, we know it. Service will have a fixed IP. My customers will be hitting onto this IP and then it will be taking it to it, right? So if I check it, let me create a service now, right? Because that is how you're going to access an application in the real world. So I do a kubectl expose deployment startup, and I give the name of the service as startup-svc, right? I normally use the word svc here. So if I check it out, kubectl get service, I see a service here, startup svc, right? Ignore these one. And if I describe this, kubectl describe service startup SVC, 3 endpoints are coming up here. Wonderful. So if I open one more tab, let me open one more tab here. Yeah, wonderful. Now, the customers will be hitting onto the service IP address, right? So I copy this, I go here and I do a curl on http//IP. So they will be hitting on my application without knowing that on which pod they are hitting, right? The service will be doing a round robin. Now let me do one thing, right? So the service is doing a round robin. Again, the illustration goes something like this. So 3 pods are running successfully, right? A service is there. Service will be connected to 3 pods. We have seen it in the endpoints. So your customer will be hitting onto the service and service will be doing a round robin between these 3 pods. Now, as I have told you, startup probe is one time, only at the time when the container has started. Once the container has started, right? Please understand it now. Once the container has started, after then something goes wrong in a container, right? Then startup probe is of no use. Let me show this. So what I do, I go to this, I go back. So I am going to check my pods, kubectl get pods. I'm going inside this first pod, right? This one. I go inside it. Kubectl exec-it, you know these commands, right? Startup bin bash. Let me clear this drawing, right? Yeah. So I'm going inside this bin bash. Now I am intentionally removing that file where www.html, right? I remove this file. Something happened. Remove the file. File is removed. Now startup probe cannot help. If I still check it, kubectl get pods, it is still showing the the container running here, active. Even though the application has malfunctioned in this pod, right? In this container. And if I describe the service, kubectl describes service startup SVC, I still see 3 endpoints. That means when the customer is hitting, when the request is going to these 2 pods, they will be getting the right application page. But whenever the request goes to this, they should be getting the default Apache page, right? Now let's check it out, guys. If I do a curl, okay, let's try this, right? See, wow, someone is getting a default Apache page. So some customers are saying, hey, the application is running perfect for me, right? They are saying the application is running perfect for me. He's also saying the application is running perfect for me. But the other guy says, no, it is not working. I'm seeing the default Apache page. So when this customer has hit on the service, his request, because it is doing a round robin, his request has gone to the first pod, this one, where I had removed the file. So this is not at all good. This is not at all expected whenever you are running application, right? Good, bad, good, bad, good, bad, no. So this is the startup probe. So startup probe, the point is what I intend to make you understand. Startup probe cannot check the pod once it is running and then something bad happened in that pod. Then what's the solution? Solution is the readiness probe, which we are going to see next. So first I'm going to delete this, right? I'm going to remove this. So kubectl delete service startup SVC, and I'm going to delete. So I hope the startup probe is clear, right? So if the startup probe is successful, only then the container will be started. Otherwise, the container will not be started. Delete deployment startup, right? But the startup probe is not at all capable of checking the health of the application once the container has started. For this, we have got the readiness probe. Perfect. So let's come to the readiness probe. So we have already seen the benefit of using the startup probe. So startup probe is checked only once at the time of starting. Now the readiness probe will check whether, okay, the container has started successfully. Right. So startup probe is being successful. Now the container has started, right? Container has started his journey. So it was good. It has started properly, but is the container is still ready to work? Is the container still ready or not? Right? So container has started successfully. At that time, the startup probe was success. Fine. Then the container started running. The load was coming onto it. Request was coming onto it. Then suddenly, say after half an hour, something goes wrong. Like I had removed the file. So what should I do now? As we have seen, startup probe was not at all able to do anything. That is where the readiness probes comes into the picture. Readiness probe is something like a cron job, right? It will keep on monitoring that particular check at regular intervals. And if the check fail, the readiness probe will stop sending any request to that container, to that pod. That is the idea behind the readiness probe. So readiness probe is similar to the startup probe, but the only difference is that it is like, so consider, as I have told you, consider startup probe as add job, right? Add. Whereas your readiness probe is cron job. Cron means after continuous. So this is a one-time job. It checks, okay, I got the file, job is done. But it will keep on checking at regular intervals. The moment the check fails, say, I will give the same example, that please keep on checking var www.html. So startup probe has checked the var www.index.html file. At the time of starting, the file was there, right? But after half an hour, might be someone has removed the file. Something happened. Application is not ready. Now the question might be why the application will not be ready, right? It was ready at the startup probe. It might be overloaded, right? Might be some of the dependencies are not available, some storage or anything. So I will keep on periodically checking it for that file. The moment the periodic check fails, right, I will stop sending request to that pod, which the startup probe was not able to do. That is the idea behind the readiness probe, something like this. So it keeps on checking that var www.html index.html file, and the request will be sent only when it is ready. If it is not ready, it will not send the request to that pod, so that the customers will not be getting the default Apache page or a wrong page. So let's try it, how it works. Let's check it out, guys, right? So again, I have another sample deployment for you. So let's take the example of readiness probe. So guys, now let's take the readiness probe. So again, I'm going to use a file. So Vim, this time I'm going to use the readiness one. Now same stuff here. Now in this file, the deployment name is readiness, replica is 3, ignore it. This contains startup probe also, right? And this contains the readiness probe also. Now we need to understand these values. What are these values here, right? So this is the readiness probe block. So what I'm saying, okay, startup probe is successful. Ignore this. We had already learned about this. Now, the readiness probe will keep on checking for this file, right? It will keep on checking for this file, whether this file is available or not. Once the pod is started, after the initial delay of 10 seconds, means suppose this is the time when the pod has started, right? So after the delay of 10 seconds, right? After the delay of 10 seconds, it will keep on looking for, it will keep on asking the question, hey, can I access var www.html index.html? That is the period second delay. And the period second is, it will keep on asking this question after every 10 seconds, right? Initial delay is the initial time when the container has started. It will give 10 seconds. Then after every 10 seconds, it will keep on asking. Timeout is 4 seconds. Timeout 4 seconds means what? Timeout 4 seconds means that if suppose at 20 seconds, right? So 10 second was there. So at 11th second, it asks, hey, can I access var www.html index.html file? And we'll wait for 4 seconds, nah? Because the container might be like busy in catering the request. It will wait for a couple of seconds. So the period, the timeout second is 4, means I should get the answer within 4 seconds. If it gets the answer within 4 seconds, perfectful. That means the container is still live. Keep on sending request. Right, it will keep on doing it after every 10 second of gap, right? Keep on doing it after every 10 second. Failure threshold is 2, means if it didn't get the response in 4 seconds, shall I consider the container down? No. If there are 2 subsequent failures, right? Means 10 seconds and then 10 seconds. Failure threshold 2. Then the container will be considered as down and no more traffic will be sent to that particular container, right? And success is 1, means once, obviously when the container is down, someone will look into it, check what happened, then it will come back again, right? So let's try this. So what I'm going to do, I'm going to again first clear this, now run this. So startup probe will be successful. And then we will do some stupid things there to have the errors. So let's create it. Kubectl create -f dep readiness. This is created. So if I check it out, kubectl get deployment. I'm getting my deployment. I am getting the replica set. I am getting the pods. And if I describe you the first pod, which is running, kubectl describe pod readiness, right? So I can see there both the startup probe and the readiness probe is successful, right? Container has started successfully. Now let me create a service because we need to create a service, right? So if I do a kubectl get pods, and I do a kubectl expose deployment readiness, and I give the name of my services readiness-svc, right? Now this means I have done the same stuff. I have 3 containers which are created from a deployment. We have a service will be connected to these 3 pods, right? And we will be hitting onto the service IP, and service will be doing a round robin between these 3, right? Round robin. So we have created a service, and if I describe the service, I should be getting 3 endpoints, right? Kubectl get pods -o wide, and if I give the command kubectl describe service readiness svc, I see the same IPs 171, 165 and 72, right? 171, 165 and 72. So customer will be hitting onto the service IP. So let's do it, right? So now they are hitting onto a different IP. Obviously we have removed the service, right? Everyone is getting the same application because it's a replica set, obviously. Now let's do the same thing which we had done while we had configured only the startup probe. Now something happened with a particular pod, right? Something happened. So I describe it. I take the first one. Just remember the IP 171, right? I take this one. I go inside this kubectl exec-it and this one and bin bash, and I go inside var www.html. I see the file. I am doing the same thing which I had done while I had configured only the startup probe. Now I removed the file. So that means what? My readiness probe should fail. Get pods. If I describe it, kubectl describe pod, this, see, readiness probe failed. So what's the benefit? The pod container become unhealthy. The container become unhealthy. You will see it is 0 by 1, right? And what is the effect then? What's the benefit? The benefit is that if you describe the service, describe service readiness.svc, you see 2 endpoints. Wow, 171 is gone. Right? So now this will not be like felt by the customers. Customer will keep on hitting onto the service IP. They are getting the request. They are getting the right application. So if the one container is down, I hope you have understood it. One container is down, it has malfunctioned. Service readiness probe will make this as unhealthy, and the service will remove that IP from the endpoint. So now the service will be doing a round robin only between the healthy pods, right? These two. So none of the customers will be complaining that, oh, I'm getting a different page or a default page, which was happening when we had configured only the startup probe, right? Now, this is the benefit of using the readiness probe, but there is a problem here. The problem is that, okay, see, if I again give the pods, it is not restarted, right? It just quarantine that. What it does, it simply make that pod isolated, that particular container get quarantined. The readiness probe will not do anything to recover, right, or to make it good again. But it does at least a very good thing, that it isolate or quarantine that container so that the request should not be sent to the unhealthy pod. But isn't it, if it becomes unhealthy, then I should do something, right? Kubernetes should do something. Let's say a restart if it is unhealthy. That is where the liveness probe will come into the picture. Now, the last probe we have is the liveness probe. The difference between the readiness probe and the liveness probe is that liveness probe will try to automatically solve the problem by doing a restart, of the container, right? So your application might be not responsive. A lot of reasons can be there. A bug in the system, waiting for something else, too much overloaded, overwhelming request is coming up, right? It stopped responding. The best way to do is, okay, it's unhealthy, let me try to do a restart. That is where the liveness probe will come into the picture. So we will configure it, but so what it does, it again, like the readiness probe, it keeps on checking for a particular time interval. Like if you see the picture here, so the container is ready, right? Now again, the period second is 10. So after a delay of 10 seconds, this much of time, right? It will keep on like sending, after every 10 seconds, it will keep on sending this, like the probes to check where www.html index.html file. And again, the timeout is 4 seconds, right? So it will ask for the index.html file and wait for 4 seconds. If it gets the file within the 4 seconds, that means the container is live. Wonderful. But if there is a subsequent 2 times failure, in my case, I have done a 2-time failure, right? If there is a subsequent 2-time failures, then the container will be considered as dead and the container here will be restarted, right? Automatically. So that means in my case, failure threshold is 2 and period second is 10. That means if continuously for 20 seconds, I am not able to get the index.html file, I will restart the container. This is what it does. And if there are some problems, that file is missing or something is missing, it will automatically be resolved, or at least it should try to resolve it. That is the idea behind the liveness probe. So the only difference is that it will restart the unhealthy container. If you have configured the liveness probe, might be we will be able to recover it. So let's see it. So this is going to be the last probe. So again, we will check the file. I have a file here, dep liveness, last one. You all know the stuff. You are champions now, by now. And this, so in this deployment, see, I'm using the startup probe to initially check whether the container has started successfully or not. Readiness probe, is it still working properly or not? And liveness probe, shall I do something in case it is unhealthy? Right? So these are the parameters which I had defined here. This is my bar which is coming up here. So this one is the one, liveness probe. So what I have done here, check this one. This is the one. This is the liveness probe thing. So again, I'm referring the same file, initial delay of 10 seconds, right? Period 10 seconds. So, okay. One important thing which you should remember is the timing are very, very important. See, I had done the initial delay of 10 seconds here in the readiness probe and the initial delay of 10 seconds here in the liveness probe. Both should match. Means they both will give container 10 seconds to start, right? After the 10 seconds, both the probes will start. The readiness probe will also start and the liveness probe will also start, right? So make sure the timings are good. Now, this will keep on recurring after every 10 seconds. We'll wait for the 4 seconds before to get the file. Failure threshold I had done is 6. Here the failure threshold is 2. Now please understand this. Suppose the yellow one is the readiness probe. So if 2 times, means 10 seconds, right? If 2 times I'm not able to get the file, where www.html index.html, consider every x as a 10 second, right? 10 seconds, 10 seconds. So if for two times, if I'm not able to get the file, the container will be quarantined, right? The container will be quarantined means there will be no more traffic coming onto this pod. But okay, let me take the say the blue one, the blue color as the liveness probe. Liveness probe will go for 6 times, right? That means 60 seconds, right? Here 6. So if he's not able to get the file continually for 6 times, that means 60 seconds here. So after 20 seconds, there will be no more traffic coming onto this pod, which is being done by the readiness probe. Readiness probe will make sure no more traffic will come to this pod after 20 seconds, right? But the liveness probe will give it a chance. We'll wait for more 40 seconds. Even after waiting for 40 seconds, if we are not able to get the file index.html, here at this point of time, the container will be restarted, right? The container will be restarted. So the timing should be, you have to take care of the timing. So let's see it. We will again create a service and again do some stuff, intentionally make the pod unhealthy, and we will see it. Now, after save and come out, I run this kubectl create -f dep liveness. It is being created. So if I do a kubectl get deployment and kubectl get pod, it should be ready. Yeah, 0 by 1. See, they are checking the startup probe and all those probes, right? So if I check one, I'll show you. Let's check the healthy one first. I copy the first one as usual, and I give a kubectl describe pod and this one, right? And you can see all the 3 probes are successful. Here the failure is 6, failure is 2, failure is 3, right? And the container has started successfully, nothing wrong in any of the containers, and all the containers are running properly. And I do a -o(y) to get the IP addresses. Now I need to create a service. I do create a service kubectl expose deployment liveness, right? And the name of the service I give is liveness-svc, right? So if I describe the service kubectl describe service liveness, so 3 endpoints will be there which will correspond to the IP addresses of the pod. Perfectful. So the customers will be hitting onto this, right? Let me go on to the second tab, our trusted second tab, and we'll start hitting onto this. Right, this is it. Perfect. So the Kubernetes is doing a round robin, the customers and I am least bothered on which pod they are hitting. Perfect. Now let's intentionally make a pod unhealthy, right? Let's intentionally make a pod unhealthy. What I do, I'll again go to the same pod, IP address 77, right? I do a kubectl. I'm going to go inside this pod. Kubectl describe pod. See, there are no restarts, right? Describe pod, not the describe pod, sorry, exec, sorry. Kubectl exec -it pod bin bash, right? I'm again going to remove that file. I go to where html, the file exists. I does some nonsense thing here, means application malfunction, something happened, not a problem, exit it. Now what will happen? Now check it out, guys. Kubectl describe pod and whatever the pod is, right? It is still healthy, right? It is still healthy. Okay, if I do a kubectl get pods, it is still, because it takes 20 seconds, right? After 20 seconds, see here, Readiness probe fails, right? The Readiness probe fails. The moment the Readiness probe fails, that becomes quarantined. That IP will be removed. Kubectl describe service liveness, that IP will be removed. Perfect. But if I do a get pod, it's still not restarted because 60 seconds, right? Now if I describe it, see liveness probe fail, fine, it is waiting 60 seconds, right? I had intentionally made this slightly lengthy time so that I'll be able to show it to you. It is failed 5 times, right? Failed, the container restarted, right? See here, liveness probe failed and the container for 60 seconds, the container is restarted. And the moment the container is restarted, see, it is restarted 13 seconds ago, the container will be restarted and obviously the file which I have removed will be come back, right? Because that is a ephemeral storage, right? So the file exists in the image. So the file comes back, the container becomes ready again, the container becomes ready again. That means it automatically comes in the service endpoint 77. See, the IP didn't change. Please understand this. The pod hasn't restarted. The container restarted. So the network namespace was kept. Right? So the IP will be same. But now because it is healthy, it comes automatically inside the endpoints and the load will be distributed to it. Customer is not at all aware of what happened at the background. So that is the relevance of using liveness probe. I sincerely hope I was able to explain you the probes in the easy word. For more details about the courses that we offer, please visit the URL which is there on the line. My phone number is also there. And if you are really interested in learning the things in the detail, then I highly recommend you to join our DevOps Master Program. And that's all for this video. Thank you very much. God bless. Take care. Jai Hind.